Today we're going to continue our lesson on simplifying expressions. In our last class we talked about simplifying numeric expressions using order of operations, and today we're going to look at simplifying algebraic expressions. We're not going to evaluate them, we're just going to simplify them. But there are some key terms that we should be comfortable with in order to do this. In an expression like 2x plus 3, it has two different or distinct terms. We have our 2x as one term and 3 as the other. These terms are not like each other. One contains a variable and one does not. In the term 2x, the 2, which is the number in front of the variable, is called the coefficient. And in an expression like 4x squared plus 3x squared, these two terms, 4x squared and the second term, 3x squared, are what we call like terms. Like terms are parts of an expression that have the same variable raised to the same power. In an expression like 5x plus 3, that 3 is called a constant. So again, these are some key terms that we need to know in order to simplify. We want to know what a coefficient is. We want to know what like terms are. We want to know what a constant is. And again, coefficients are numbers in front of a variable. When I have a term like 2x, that coefficient is 2. If I had an expression like x plus 1 or x plus 4, let's say, the coefficient in front of the x would be a 1. Let's take a look at some problems to simplify. If I want to combine like terms, I'm going to look for, again, terms with the same variable raised to the same power. In this case, I have the 4x and 6x, which are like each other, so all I need to do is add the coefficients. And then I just bring the 2 along because there's nothing to combine with the 2. Looking for like terms, I notice that the first two terms in the second problem up top have the same coefficient, x, raised to the same power, 2. 9x squared minus a 3x squared will give me a 6x squared. There's nothing like 4x. I'll just bring that down, and that constant will come down as well. Looking at my next problem, this time I have an 8x squared and an x. Now I could, if I wanted to, and again we talked about properties, I could commute this, and if I wanted to, I could put that 8x next to the x, and then the constants next to each other, and then I would get my 9x, and then I would have 5 minus 2 is 3. And that's as simple as that can go. I can't do anything else to that problem. I can't combine the 9x and 3. They're not like terms. Now I look at this fourth problem, and I have a 12x squared and a negative 2x squared. Now I'm going to circle this first term, circle the third term. And notice as I'm circling it, I'm keeping the sign in front of it, because if I wanted to rewrite this, I would make sure the sign that was in front of it goes along with it. I then have my 9x. It's going to go right next to my 6x minus 4. Now you don't have to rewrite it. You can look at it and just combine these two, then combine those two. Sometimes I like to write it so as I don't get confused. I now can go from left to right, and I see that this is going to be a 10x squared. I have a 9x plus a 6x will give me 15x minus 4. Let's try 2 more. Now this time I notice that the x terms are in the center, and y terms, which are right here and here, and again as I circled it, you notice that I included the sign in front. That gives me a 7y plus 3y plus 4x minus 3x. Keeping the signs in front. 7x plus 3x will give me 7y plus 3y will give me 10y. 4x minus 3x will just give me an x. I don't need to put the 1 in front. This next one has a combination of variables, but again, these two are like terms, so I can take those and add the coefficients. These are also like terms, so I can go ahead and subtract 1y from 4y, and that will give me 3y. Now, in our Zoom class, we'll do a few additional problems, but this was just a highlight so that you could see this in the video if you had time before class. If not, then we'll work on it today in class, and today we meet 6th period. No, we don't. We meet 4th period. So I will see you 4th period. Until then, have a good day.